back to our channel, that is AI next generation. In this particular video we will see how to create a RNN model, as we have done the previous, that is we have done the CNN model, how to build the CNN model, how to build the ANN model, okay, and rest what is the basics of the PyTorch and data in the PyTorch data loader, okay. So we have gone through this particular concept. Now we will just make another model, that is a RNN model, okay. So you already have built the ANN model, you already built the CNN model. Now this time we will build the RNN model, okay, that is a recurrent neural network, okay. But the thing is that whenever you are dealing with the images of the data, at that time RNN you are not going to use, because it will not give you that much accuracy what the CNN it is giving. Even we will see this thing in the training time. Whenever we will train this data, that is we have just taken the MNIST data set, then you are able to see which particular model is giving a good accuracy. Because for the CNN, if you are just dealing with the images data, videos data, then directly go for the CNN, convolution neural network, okay. So that will give you a higher accuracy as compared to the ANN and even the RNN, okay. So now the thing is that you have to know how to build a RNN model, okay. If you are just using this thing for the sequence of the text, okay, or sequence of the data, that is a text file, then at that case you have to use recurrent neural network, okay. An advanced version is like a long short term memory, that is a LSTM, okay. So I don't think so you have doubt what I'm going to start today. So for that you just build the class RNN. So if already you have gone through the ANN model, how to build the ANN model, how to build the CNN model in the previous video, so you will able to understand each and everything what we are going through the step by step. And it is not really complicated. You have to only give the hidden state and cell state, memory state, because in this RNN there is they only use the memory state, means what previous they have just learned from this previous data, they are just predicting the future, okay. That is happening in this RNN. So they are just taking the sequence of the data. So I will just go step by step so you will able to understand. So first of all you are just creating the RNN model, okay. So in that you are just inheriting this module, okay. So we are just inheriting this module. Then after the similarly you are just defining the constructor, that is init method of the RNN, and here you are just passing the self. I am just doing the hard code of this, okay. So whenever for that, then after that what you have to do, you have to initialize this particular parent class, parent init or parent constructor. This is the nn dot module, okay. For that you can use the super, okay. So super you have to just pass rnn comma self, and you have to just initialize the init method of the parent class, okay. So you already have done this thing already. I explained in the previous video much detail, okay. So now it's clear. Now we will start to build the model of the related to the LSTM or RNN, okay. The first we will take on at the LSTM, that is the more advanced version of the RNN, because you know that in LSTM you have three gates, you have input gates, you have output gate, you have forget gate, okay. So they are in the theoretical part. You can just, even I will just give you the link in my description video, so you will able to go and read there about the theoretical part. I'm just this video I'm just concentrate in this particular how to build this particular RNN model, okay. So yeah, we can just start with that. So the first thing, already you know that LSTM, long short term memory, they have the memory cell. So memory cell in the LSTM, it is really important thing that was not present in basically in the RNN section, okay. So that's why the advanced version of RNN is the LSTM, where in the RNN you are getting some sort of vanishing gradient problem. It was there. So to overcome of that vanishing gradient problem, means you are not updating the weights, means whenever you have 200 or 300 words, you are going back to predict the future word, okay. At that case memory power of RNN was really low as compared to the LSTM. So LSTM they develop a cell state, okay. So that holds the memory, okay. What they have, the model has learned the previous or important was they are just holding in that particular memory cell. Even for that video I will just explain you the more detail of the LSTM, how it is working step by step, okay. Just concentrate for now how to build a particular LSTM model, okay. So what you can just do, you can just write rnn, okay, self.rnn, and then after that what you can just do, the first thing you have to just keep in mind that whenever you are just creating this particular hidden layer, or how many layers you want to give in this particular LSTM, you have to define here, okay. So first of all you can just do what thing, you can just do one thing. You can have to just define how many hidden state, how many cell state you want to take. Even you can just do this thing in the cell, you can just define this thing in the constructor by default. Okay, it's up to you. If I am just saying that I want input, this is what I was saying, input. If I want input size, this is the input size. So in this input size will be what? So explain me what will be the input size for this particular. So you have to give the input size as 28. Why? Because you already know that Amni's dataset has the dimension of 28 cross 28 cross 1. Okay, so you have width is 28 and the height is 28 and the number of channel is 1. Okay, so what does it mean? So 28, the first 28 pixel will go to the first, then after 28, then second, then 28, third. This step of this will be go, because 28 you have features and the sequence of that particular one image is 28, means you have 28. Okay, 28 you have 28 you have rows. Okay, 28 you have rows and 28 you have columns in that. So 28 row, one row it will go, and then sequence of that will be the total 28. Okay, so you have to give the input size as 28. Then after you have 28, then after that you have to define this particular hidden size, how much hidden size you want. So what will be the hidden size for that? So hidden size you have to define here. You can just mention here how many. You can just give, already we have seen in the hidden size, we are using the ANN model, that is we have kept I think 256. Even you can just start with the 256, so you can just mention as 256. And then after that what you can just do, then after that you have to define the number of layers, how many layers you want to kept in this particular model. Number of layer means how many LSTM layer you want to keep. That is basically one LSTM layer or two LSTM layer, they will stack one upon other. So you have to define one more layer, that is the number of layer you have to define here. So number of layers will be, sorry for that, number of layers will be here, I'm just using 2. Okay, so you can't use more than 2 or 3. You can use any number of layer, but it's depend upon your data set. If your data set is huge, you can use number of layer as 3 or 4. But whenever you're dealing with short amount of data set, at that time if you are using number of layer as 1, so number of layer as 2 and 3 also, then at that time it will give you the problem of overfitting problem or underfitting problem. That's depend upon your data set. So number of layer is up to you, how many layers you want to keep. Okay, but you have to see how many your data set is really huge or it is really light data set. Okay, so you have already have defined this thing. Then after that what you have to do, you have to define the thing is that you have to define the number of classes. Okay, so number of classes is how many classes we have. So you already know, I think number of classes is basically, I'm just taking all thing as a by default value. Okay, so you no need to again, whenever you will make the object of this particular RNN, no need to pass again this thing. And even if you want to change, you can just do this thing. But number of classes depend upon your targets. You already have 0 to 9 digit, means number of classes will be 10. Okay, so I don't think so you have problem in that. Just initialize everything first. So we can just do one thing first. You can just initialize this hidden, the first one, which is the input size. Okay, so which one we want? So hidden size we want in the for further use. Okay, so you can just define hidden size equal to hidden size, because we want this thing in the particular fully connected layer. Okay, then and even whenever you will use the forward method, at that time you will use this particular hidden state. So that's why we are just initializing this hidden state. So we are going to use in the forward method also, but the input side we are going to use here, so you no need to initialize that one. So even then after the number of layer, we are going to see how many layers we want to keep. Okay, so you can just define here, and number of layer you can just say. Okay, so it's fine. So number of layer you already have defined. Now you are just creating the LSTM layer, that is the Rnn model you are just creating. Okay, so just define self.lstm or self.lstm, you can just create. And then after that you have to keep that from nn.lstm. Okay, lstm, you have to write this thing. Okay, and then after that you have to pass the input size, the hidden size. What is the input size? You have just passed that one, that is the input size, you don't have to write here. And then after that you have to pass the hidden size. Okay, so hidden size. And then after you have to pass the number of layers you are going to use. Already we have defined this thing. And then after you have to define one more thing, that is a batch size. So batch first, sorry for that, batch first. What do you mean by the batch first? So whenever you are just specifying that batch first is equal to true, first I will just write batch first equal to true. Okay, what you are just writing this one. Okay, you are just writing batch first equal to true. What does it mean? So whenever you are writing the batch first equal to true, so it will just return the first, it will return the batch, then after it will follow the, this will be the same. Whenever it will output will come, then this will be the same, the batch, the first batch you are just want to see. And then after hidden size you want to keep hidden size, that is the timestamp you can just say. And then after input size. Okay, this way the output will be, if you are specifying the batch first equal to true, because you want the, you already done in the AN and LSTM already, you have seen the batch, you are just writing the batch, then after followed by height and width and number of channel, followed by that. Okay, the same way what you have to specify, you have to specify batch first equal to true. By default it is false. Okay, so whenever you are specifying batch first equal to true, then output of that particular LSTM will be the first way, it will go for the batch. Okay, what will be the batch, and then after it will follow to the hidden size, and then after it will follow input size. Okay, so I don't need, you don't have doubt in this, I think it's really easy. And after that what you have to just create, you have to create one fully connected layer. I'm just creating one LSTM layer. Okay, LSTM, then that has two layers. Then after sorry for that, then after that you are just creating the fully connected layer that already we are seeing. So what you have to just write linear, and then after that you have to pass the number of you have to pass the number of hidden size. Okay, so hidden size into what will be, you will pass the sequence length. Okay, so what do you mean by hidden size into sequence length? Okay, so you have to pass these things, and what will be the output for that? So the sequence length is basically, you can just say how many sequence length you want to keep. I think we have not defined the sequence length, you can just define here also, no need, no problem. Even you can pass the sequence length as 21 28, because 28 input size you will go, and then after the total 28 cross 28 you have the 28, the first rows it will go 28, that is the input size. Okay, you are keeping for the RNN, then after followed by 28 28 28. Okay, so that is just the sequence length. Okay, so you are just keeping the sequence length here. So you are just keeping the sequence length here, you are just, sorry for that, sequence length, if we are just keeping, we are just keeping as 28. Okay, so no doubt in this also. So here what you have to pass here, whenever you are just creating this thing, so how many layer in that, so what will be the last layer, the last layer you are going for the fully connected layer, that's what you are going to use. That will be the what will the sequence length into the hidden size, that will be the output. Okay, so what you can just do, sequence length into hidden size. Okay, hidden size. Okay, so this will, and then after the, what will be the in output number of neuron, that will be the, depends upon number of classes you are going to use. Okay, so what does mean it, you already seen this thing, but what does it mean, what I have just created this one. Okay, so this is basically that sequence length you are just taking into hidden size, what you are going to use. So what will be the output for that? So actually the main thing here is that the number of sequence length you are going to use, it's a 28. Okay, so 28, and then after you are going to use the, basically what you are going to use, first of all sequence length, then after you're going to use the hidden size. So what is the hidden size, you are just specifying here the 256. That is really huge, you can just even keep it light also, but no problem for that. So you are just keeping as the sorry for that, you are just writing as the hidden size into sequence length. Okay, so I don't think so you have problem in this. So it's quite clear. Now after that you have to define the forward method. Okay, the forward method you have to define, and here you have to pass the, basically the self comma the images you want to going to pass. Okay, so this thing is really easy, you already have make the constructor for that, you already have the super method, you already have the hidden size, you are just initializing this hidden size and number of layer, you are going to use this thing in the forward method, that's why you are just initializing this two. Okay, and rest you are not initializing this one. Okay, and then after that you are just making one LSTM layer, you are using this LSTM layer, and it takes three parameter, that is the input size, what will be the input, the first input to that particular LSTM, you are just giving as 28. Okay, that, and then after what will be the hidden size, you already defined here, that is the 256, and what will be the and you are just specifying like batch first equal to true. Okay, so batch first equal to true means whenever the LSTM will return the output, that will be the shape of batch size and hidden, followed by hidden size and input size. Okay, that will be the shape of that. Okay, then after you are just following with the fully connected layer, that you will, that is the last input what you are, what you will get from the last LSTM layer. Okay, that will be your, you will fit to that first fully connected layer, that is you only one fully connected layer you're defining. So that will be the last is the hidden size. What is the total hidden size? You're just specifying 256, okay. And then after sequence of the length, all the 28 sequence of the length, you are just multiplying so that it can directly fit to that particular. You are just keeping this particular to the input layer, and then after you are just number of layer you are keeping in the output layer, okay. So you are just creating only one fully connected layer. So I don't think so you have problem in this. So now what you can just do, now you have to make, you have to initialize the hidden state and cell state for this particular LSTM, okay. Because the hidden state and cell state previous, the first time it will be the zeros, then after it, whenever it will go for the second hidden second sequence, then third sequence, then fourth sequence, then you will have some hidden state and cell state, memory state. So that, but initially you are going to directly fill the data, so there is no previous input. So at that time you have to initialize with the 0. So what you can just write here as 0, you can just write here, and you have to just initialize with the torch.0, okay. So you can just write torch.0, and here you have to pass self dot number of layer you are going to take. So number of layer we are keeping as 2. It takes the first parameter, that is the number of layer we are taking as 2, and then after you are just, you have to specify the the batch size, okay. So batch size, it is whenever you will do the image dot size, okay, the first thing it will appear the batch size. The first thing it will appear as the what you are going to use here in the batch size, okay. So what you will write here for the batch size, you will just mention as 0. The first thing, that is the batch size, we are already have taken, I think 64 we have taken, that this will be the pass here, okay. And the third thing is that you have to say hidden size, okay. So what will be the hidden size for that, okay. Cell but hidden size already you have defined. So this is the same way you have to write for this particular cell state, okay. The same way we have to write for the cell state, but change from S0 to C0, okay. So yeah, this was the, you are just initializing the hidden state and cell state in this particular LSTM layer, okay. So then after that, what you are going to use, you are just writing the output, okay? So you are just writing the output. It will just see the self.lstm will return the two things. One will be your output, and other you don't want that particular bit, because it will give you the all the hidden state what was the output. So you no need only the last, what is the hidden state, what is the output you are just mentioning, so that you can directly fit to the fully connected layer. Because what will be the last output of the LSTM, that particular you want to take and you want to fit into the first fully connected layer, that's what you are going to use, okay. So for that, what you are going to write here, you have to just create self.lstm. Already you have just initialized before this, already you have just created. And then after that you have to pass the data, that is the images, this is the data over. And then after you have to say hidden state and the cell state, hidden state comma cell state, in this tuple form, okay. What I'm just writing here, you have to write here, okay, cell state. So what you are just doing here, so it will just, LSTM will return two output, two things, that is the output what the LSTM has given you, the output, the last layer, so that you can directly fill to the fully connected layer. And this thing is the all hidden state what you are getting the outputs for that, okay. So here, and then self dot, that you don't need this one, that is the useless for this particular problem. And then self.lstm, it takes two parameter, that already I've said, that is the image, you are just directly passing this. And then after, what you are going to use, then after you are just going to use hidden state and cell state, okay. So you are just passing the hidden state and cell state. Initially you are going you are just initializing as a zeros, okay. Then after that you will just reshape this thing, okay, so that you can directly fit to the fully connected layer, okay. So output you are just getting, from output, or you want only the last one, the output you are getting for the all the 28, or the all the 28 sequence lengths, and the last sequence lengths you will keep to directly to the fully connected layer, okay. So what you are going to write, you want to reshape this thing. So you can just do reshape, and then after that, what you are going to reshape with output, sorry for that, out dot, what is the shape of this, and you want only the first, that is the batch, the last one, and you want only for the last, this what you want to say, okay. So output dot save will just return whenever you will do the training part, you will able to see. So output is basically, it will return into batch size. So what I've said, batch size, hidden size, and the input size, what it will just return, okay. So from that you want only the batch size, and then after you are from that batch size, you want only the last, okay, the last layer for that, so that you can directly fit to the fully connected layer, okay. So yeah, it was really easy. And then after, you have to define self dot fully connected layer, that's the, already you have just created, just pass this out, that's it. and just return this. And this is your, you have created this this is you have created the LSTM or RNN model. Okay, so you will see this thing more detail whenever you will do the sequence of the data that I will just upload. We will do some projects related to the LSTM or RNN, so at the time you will see more thing about the RNN model. Here I'm just using for the images of data, and images of data you are not going to use that much for the RNN, because at that time you will get, your CNN model will give you higher accuracy as compared to the ANN or RNN. So that's case you are just, RNN is only working the best working on the sequence of the data. So you are just fitting the sequence of the text, so they, and then after on the basis of the sequence of the text, they are just predicting the what will be the output on the previous cell state. Okay, and previous you have cell state and memory state. Okay, so this is what the RN we have just created. I will go in the brief again. This is what you have done. Then after you have just make the constructor. Then you have just initialize the hidden state number of layer. Then after you have just create the LSTM. Okay, and in LSTM you are just passing the input size, hidden size, and number of layer, and you have to specify batch first equal to true. If you are not specifying, then batch will be the in the middle one. Okay, so you are just specifying batch first equal to true, it will just give you the output in the shape of batch size, hidden size, and input size. Okay, then after you are just creating the fully connected layer so that you are able to train the model, so on the basic of number of class you have. Okay, then after you're just creating the forward method and you're just passing this image, then you are just initializing the cell state and memory state and hidden state for this particular LSTM, because the first time you don't have any previous inputs, so that's why you are just initializing all things into zeros. Then after you are just you are just using self.lstm, what you have just initialized here, and it takes two parameter, that is the image and cell state and memory state in the tuples form. Okay, that will give you the output, and this is the all the sequence, all the hidden state, what was the output. So you need only the output, the last output. Okay, and from the last output you want the last sequence length, so that you can directly fit to the fully connected layer. What you are going to write here, -1. Okay, the last one, and then after you will get some output. Okay, this is what was the RNN. So you can just make the object for that, you can just write RNN, that's it. Okay, so this was the ready to what I have done. I have to just write capital N, no small n. Okay, just run this one again. I hope so it will run. Yeah, so this was the, and you can just see the parameter of this. If I'm just writing printing RNN, so what you are going to see, this is here the parameter. Okay, so this really small, but yeah, you are using two layers in this LSTM. So that's, this was the how to create a RNN model. In the next video we will going to see, we will train the that is ANN model, we will train the CNN model, we will train the RNN model. Okay, so we will see the result of every model what we have done till now. So hope so you are clear with that, and if you like our channel, please subscribe our channel. That's it, thank you.